All right, so chapter six test review video number 2. So in this one, I'm going to go over the free response portion. So let X denote the number of absences for a randomly selected student from math class in 1 week. So we got a distribution of X. So find and interpret the mean or expected value of X. So on a multiple choice, I would expect you to just put the X's into list 1, put these into list 2, do the one of our stats with L2 as the frequency list, and get the mean. Okay, no work required. On a free response, you must show the first calculation and the last calculation. So mean of X, 0 times 0.78 plus plus, and then show the last calculation. Okay, then you can do the behind the scenes work of like what I said, putting that into list 1, list 2, doing one of our stats, L2 is the frequency list, to get the average of 0.38. Okay, now what does that mean? So interpreting it, so this is the interpret piece. If many students are randomly selected, their average number of absences from math class will be about 0.38. Okay, so that's the interpretation piece. Find the standard deviation of X. Find and interpret the standard deviation of X. So again, doing that one of our stats, it already gave you what the standard deviation is, so you already have that answer. But for free response purposes, we need to show the first calculation and show the last calculation. So first calculation would be first data value, so 0 minus the mean, squared times the probability of 0, which from that table was 0.78. Plus plus, and then show the last calculation with the data value of 4. So 4 minus the mean squared times the probability of the data value of 4, 0.01. And again, from that one var stats readout, we should have got a standard deviation of about 0.82. So again, that interpretation piece, if many students are randomly selected, their number of absences from math class will typically vary by about the standard deviation, so by about 0.82 absences from the mean of 0.38 absences. Part C. I'm glad this is not the case. Suppose my pay gets docked $1.50 for every time a student is absent from my class. My normal pay per student is $6, not the case, but that is pay equals, so the new pay would be 6 minus 1.5x, where P is the pay per student. Use a linear transformation of your results from part A and B to find the mean and standard deviation for P. Well, so for the mean of P, we'd have 6 minus 1.5 times the average we found above. So we'd get a transformed mean of an average of 5.43 per student. Now, for the standard deviation, we're not going to get the 6 minus part, it's just going to be the multiply part. So for the standard deviation of P, it would just be the 1.5 times the 0.82, the standard deviation from above, to get a standard deviation of 1.23. Okay. Now in this one, we just had to find it. We didn't need to do the interpreting, so that's all we got to do. Okay, next page. The amount of time it takes a student to do their calculus homework. Followed a normal distribution with a mean 25, standard deviation 5, it's normal. Choose 2 students independently at random from this group. What is the expected difference in their calculus homework completion time? Show your work. So I'm going to, because we're probably going to use some variables here, I'm going to say let A equal, let's go student 1. I suppose we could just let A and B equal the 2 random students, because then I can do, so the mean of A minus B would be just subtracting the means. For means, remember, we can just subtract them. So if one student's average is 25, another student's average is 25, then the expected difference would be 0. For standard deviations, we can't just add the standard deviations and say it's going to be 10, or subtract them and say it's going to be 0. We still have to square the standard deviations to get the variances, add them together, and take the square root. So standard deviation of a minus b would still be the square root of the standard deviation of a squared plus the standard deviation of b squared. Okay, so square root of 5 squared plus 5 squared, or the square root of 50, which would be about 7.07. Part C, find the probability that the difference in the two scores is greater than 6 in either direction. Okay, so what does that mean? So normal, right, set up in the directions, it was a normal distribution. So if you have a normal distribution and a normal distribution, and whether you're adding those two distributions or finding the difference of those two distributions, the result is always going to be a normal distribution. So normal distribution, expected difference would be the mean we found in part A, 0. Standard deviation, 7.07. So we want that the difference in the two sum scores is greater than 6 in either direction. So is it greater than positive 6? Or is it greater than negative 6? So we need to find both tails of this. So we would need to find the probability that the difference a minus b is greater than 6, or the probability that a minus b is less than negative 6. So we gotta find both directions. So for this one, normal CEF, greater than 6, so lower bound 6, upper bound positive infinity, mean 0, standard deviation 7.07. So this would be for this calculation, and we'd want to add that to, because it's or, we'd want to add that to this calculation. So normal CDF again, but less than negative 6. So lower bound negative infinity, upper bound negative 6, mean 0, standard deviation 7.07. So we have two different calculations we got to do here. When we do those, we add them together. We should get 0.0, or not 0.396, I believe. Okay. So there's about a 39.6% chance that the difference in the two student scores will be greater than 6. Okay, whether it's greater than positive 6 or greater than negative 6. Okay. All right, 3. Study shows that 66% of all dog owners greet their dog before they greet their spouse or children when they get home from work. Assume that the claim is true and that each arrival home is independent. In a series of arriving home from work, what is the probability that the first time a person doesn't greet their dog first is on the 5th arrival home? Okay, so not normal, right? Doesn't say anything about normal. Is there a set number of trials for A? Okay, not really. We want the first success to be on the 5th one. So it's not like 5 out of 10 or 5 out of 20. There's not a set trial size, which would mean this is going to be a geometric distribution for part A. So because we're going to have a probability statement, sorry, we're going to have to define X. So let X equal the, sorry, let X equal the number of times arriving home before not greeting the dog first. Okay, so then with these, as hopefully I have taught you throughout the chapter, we need to state what kind of a distribution x is going to follow. So we said x is geometric with a probability of success of, now what do we want to use here? So it's phrased in the question as 66% of all dog owners greet their dog before they greet their spouse, okay? But in the part A, we want to find the probability that the first time a person doesn't greet their dog. So we would actually want to use the complement of this percent for here. So we want to use 0.34 instead of 0.66, okay? So if you're going to use the geometric command in the calculator, the geomet PDF, we want it first on the fifth arrival home, so probably that x equals 5. So geomet PDF, okay, and with geomet, your calculator prompts you for two things, right? It prompts you for p, 0.34, and it prompts you for x, which in this case would be 5. Okay, so second vars on your calculator, might want to click up because it's geometric at the bottom. So geomet PDF of that, we get 0.0645. Okay, so you could have done it that way, or you could have just thought through this without using the geomet PDF command, because we could have said probability that x equals 5, and probability-wise, if the first time the person doesn't greet their dog is on the fifth one, that means the first 4 times they greeted their dog first. So 0.66 to the fourth, and then on the fifth trial they didn't greet their dog. So doing this was going to give you the same exact answer you would get over here. Okay. Okay, part B. What is the probability that a person greets their dog first on 4 or fewer of the next 10 arrivals home? Okay, now this is going to be a binomial situation because 4 or fewer of the next 10. So we have a set trial size here. So we're going to have to define a new variable. We used x as geometric, which means we need a new variable. Let's just say y. So let y equal number of times greeting the dog first when arriving home. Greeting the first. Okay, so then y is binomial with trial size of 10 and probability of success of 0.66. So 4 or fewer would mean find the probability that y is less than or equal to 4. So with less than or equal to or inequalities, we use the CDF portion of the binom command. And binomial CDF or binom CDF always gives you probability less than or equal to, so we don't have to do anything fancy here with rewriting the probability statement. So N10, P.66, X4. So that gives us 0.03, 0.0836. Okay. Suppose that person goes on vacation for 2 weeks. When he returns, he greets his dog first only 2 of the next 10 days. Is this evidence that his rate is now less than 66%? Okay, so because that didn't really work. So 2 of the next 10. So this is still a binomial situation because we have a set trial size. Okay, so we don't have to redefine y. We can just move on to finding the probability. So only 2 of the next 10 days. So probability that y equals 2 okay. So again, second vars. Equals 0.0035. Okay? So is that probability significant? Well, hopefully you remember yes. So because that's less than 0.05, that means that that result is significant. So there's about a 0.35% chance that this would happen. So either the success rate changed or something happened on this vacation that is causing this difference, right? Because this is significant. So he's not grading them only 2 out of 10 days just due to random chance. Or something happened on vacation to cause this result. Okay? Maybe he got bit by a dog or something. I don't know. Something happened. All right, question 4. All right, weights of adult men, approximately normally distributed, mean 200 pounds, standard deviation 35 pounds. If you randomly select 3 men, what are the mean and standard deviation of the sum of their weights? Okay, so we're gonna have to combine 3 means and 3 standard deviations, which means we're gonna need a variable to represent that we're finding the total or that we're finding the sum. So I'm just gonna say a t equal the total weight of 3 men, 3 adult men. Okay, so for the mean of t, means we can just combine them, right? So 200 plus 200 plus 200, so 600 pounds. Okay, for the standard deviation of t, again, we have to combine the variances. Okay, so 35 squared plus 35 squared plus 35 squared, which means we would get a standard deviation for the total weights of about 60.62 pounds. Okay, so that's all we had to do for part A, was we had to define a variable, find the combined mean, find the combined standard deviation. An elevator in a large apartment building has a maximum weight capacity of 700 pounds. If 3 randomly selected adult men get on the elevator, what is the probability that they exceed the maximum capacity? Okay, so again, it said in the question up above that it's normal, and if you're combining normal variables, then the result is going to be normal. So you can use a normal distribution, mean 600, standard deviation 60.62, and we want to find, if the maximum capacity is 700, we want to find the probability that they exceed that capacity. So we want to find the probability that the total weight is going to be over 700. So we want to find the probability that t is greater than 700. So normal CDF, lower bound 700, upper bound positive infinity, mean 600, standard deviation 60.62. So we get about a 4.95% chance that they're going to exceed the maximum capacity. Still a little bit too high of a percent chance for me. I'm not getting on. Okay, last one. All right, Ed and Adelaide attend the same high school but are in different math classes. The time E that it takes Ed to do his math homework follows a normal distribution, mean 25, standard deviation 5. Adelaide's math homework time A follows a normal distribution, mean 50, standard deviation 10. Assume E and A are independent random variables. Find the probability that Ed spent longer on his assignment than Adelaide did on hers. Okay. All right, so for these ones, we are typically, and hopefully I taught this okay throughout. Eventually, in our probability statement, we are going to be finding the probability that E is greater than A. Okay, but within a normal distribution, because this is normal, we need one of these to be a number, right? So whatever way you want to do it, I typically bring this one over here because we're going to have to then find the probability that E minus A is above 0, right? So we need a number in there to use as a bound when we go to do normal CDF. So just for sake of this, I'm going to let D equal E minus A because that's when I'm going to end up having to use. Okay, so D is E minus A. So then the mean of D would be the mean of E minus the mean of A. So mean of E was Ed, so 25, minus the mean of A, which was 50. So we get a mean difference of negative 25. Okay? That's okay. No, did I phrase that wrong? I phrased that wrong. So Ed spent longer on his assignment. That's okay. This will work out. So we did E minus A. I think I did it opposite on my answer key. That's okay. That's all right. It'll work out. So standard deviation of D equals the square root of, so standard deviation we have is 5 and 10. So 5 squared plus 10 squared. So we get a standard deviation of 11.18. Okay? So we get a mean of negative 25, standard deviation of 11.18. Okay, so normal distribution, mean, negative 25, standard deviation 11.18. So we would want to find the probability that the difference, E minus A, is what? What do we want to find? We want to find that the difference is above 0. We kind of go back to the whole E minus A above 0 thing that I started with. So normal distribution, mean, standard deviation, value of interest, find the probability above that. So lower bound 0, upper bound 1E99, mean negative 25, standard deviation 11.18. And we should get about 0.0127. Okay. I believe I just did this a little slightly different than I think on my answer key. I think on my answer key I did A minus E, so you got a positive mean. And then we were finding, again, I think on my answer key, we did the probability less than 0. But either way you set it up, you should get the same probability. Because one way you're finding the high tail, one way you're finding the low tail, which is the same probability. All right, I think that's it. Okay, hopefully that was beneficial. So we should have, again, you might be watching this, you might not be. If I'm gone, you might be watching this a little bit on the 30th. You got a multiple choice test tomorrow. Free response test on Monday. Again, depending on what I got going on when I'm gone, we might have a Teams meeting sometime, an optional one if you want to jump on, ask any questions. Make sure you're set for the test coming up. Okay, take care. Everybody have a good rest of your day.